I will point out that the Ham Sign newsletter is out. And that we won't meet next week because of Thanksgiving. I'll go ahead and put that in, a copy of that in the minutes. We do have one more grape that recently returned, and John has it now. So there will be another grape 2 ready for redeployment eventually. John, any updates from you?
No, I received the grape. I have not looked at either of the disk drive's data sets, so I have to do that yet. But other than that, I did get the grape from Narnia, and it's down here in the lab. Thank you for bringing that over. And I did print up a new box assembly for the previous grape that it got smashed, so that's been repaired. And like I said, I haven't done anything with clearing off the drive of the data, saving it, and then clearing out all of the metadata and then preparing it to be redeployed. So that's still in the works. Back to net.
Okay. A few grapes have to be smashed to make wine, so we're probably good. Is Kong on today?
Hello.
Any updates?
No, not a lot since focusing on refining my presentations, my thesis presentation. Yeah.
That's a good plan.
Not just something minor.
The midterm survival week also.
Yeah.
The students on the call. Okay. Bill, any updates? Bill Angoki, I should say.
Nothing new to report this week. Thanks.
Okay. Rob, any updates on the antenna project?
Let's see. Elmer N3AGC is experimenting with the Glenn N6GN single antenna system and has put one up at his house in an extremely compromised environment. Lots of local RFI, and saw a dramatic improvement over his previous antenna systems. So I think he has more of those single antennas. He ordered 5 of them, and I think I think that maybe in the next few weeks, Elmer might be able to ship one to Nathaniel and Jonathan for them to put up. So we'll need to probably on the side talk with maybe Jonathan or Nathaniel when he's back to order the fiberglass pole that it would mount on, and so that they have the mechanical parts. So and Michael Howen also we would get another one of those to him. I also have received the field probes, which help help. I have 5 of them now, the second batch. I don't know. I have 2 people who in my Whisper Demon group who want them. I don't know. Was there anyone in this group that's interested in the field probe? I don't recall. I shipped one to David. I think David has one. I don't know if anyone else is interested. So this is.
I had an interest if you had an extra one, but
Yeah. Yeah, I do have an extra one, but I don't, who's this? It's oh,
me, John.
okay. Oh, okay. Well, yeah. Well, that's why don't you? Do you want to send me a mailing address? I can ship it to you. And,
I can do that.
Okay. You have my email address, or put it up in the chat here. So.
Okay, yeah, I should do that. I'll get an email off. Thank you.
Okay.
Cool beans. And I imagine that the Whisper updates are
Oh yeah, the Antarctic thing. We just lacking a Jerry told me that VK whatever said that he really needed a more formal kind of presentation than just the website to present to the Australia and Antarctic management team. Um, so I didn't really have time to work on that. I mean, John, I think, or Gary, you sent me a paragraph summary, but I think that which I forwarded to him, but he didn't feel that was enough for him to make a presentation of people who didn't know anything about it. So I don't know if if you have Gary, you have plans to do something a little more formal for I don't know that that's needed elsewhere, but I would think for institutional locations like the Antarctic that the relevant authorities would want some kind of 1 or 2 page document that says who are we, what are we trying, what's the science goals, who's the organization sponsoring it, and so on. And lacking that, he felt that especially the British Antarctic people with whom Jerry Helsa has contact are looking for even, the same kind of a little more formal proposal and presentation. So,
Okay, that's fine, Rob. That makes sense. And most of my other ham side duties have rolled off for the year, so I'm going to be focusing on the deployment of the new equipment starting shortly, and I will take that under advisement and see what I can do. I'm sure I want Nathaniel or others to help me review that when I'm done, but I can work on that.
yeah, well, I've just sorry, I just have it's not something I feel like I'm the best qualified to work on. It's not trying to make it too onerous, Gary, but I do think something that kind of has a, you know, proposal format. Here is, and with some pictures of what and or diagrams of what an installation looks like would be helpful. And I think that would be helpful even for other, for the regular set of grape deployments, grape whisper demon grape deployments. So.
I agree completely. This is something we need for our NSF grant that's kicking off technically in January. So you're right.
Yeah. Yeah. Okay. Thank you. I appreciate you taking that on. So,
Gary, if you need help, I'll be glad to help you with that.
All right, Jim. Thanks.
Yeah, just been contacting by email.
Okay.
uh, I guess you could say for those updates on the rest of the stuff about AGC, I think that what we've learned is that we don't. I can eliminate AGC and just record the 32-bit floats. The way apparently, as I understand it from you, Bill, that the Grape 1 and Grape 2 record 32-bit float samples and are put into the DRF files. And so that's what I would be doing with the code that Scott has provided to me, as I'd be providing 32-bit float WAV files in there. So if there's any, that will inevitably double the size of the um, but of the data sets, but that will make them calibrated in that at that point we no longer need there will be no real need for metadata because there would be no gain adjustments of being applied to the incoming data. They would be absolute. So we need to calibrate once. We need to come up with a calibration for the 888 to the 32-bit WAV file values. But once we do that, that calibration will be the same at all times at all sites. And I think that would help the analysis of the data. You wouldn't have to look at metadata to understand what the absolute levels were.
That will greatly simplify things. And you know that if we were keeping all that metadata, it would bloat up the files anyway. So, you know.
Yeah, well,
Not too
I'm,
much.
yeah. Anyway, uh, that's my my goal for the coming week is to get that 32-bit WAV file recording and uploading going. And I'll of course I'll email the group when the data becomes 32-bit. There must be a place to put the information about the data format, the sample format in the DRF. I think that Scott heard from Franco, who is a one-line thing. So just to add this, basically, I think we'd be just saying this is 32-bit, float. Although the WAV file themselves have the header with information in it. So I think Scott added custom WAV file headers. Um, that describe the format. And more information than just the 32-bit sample size. I think there's other information that he's put in there. So the that's I think anyway. I think that's a path to that we'll be on pretty soon. So really delivering such data.
Any questions, comments, or concerns on our current projects?
Just a comment on the RX888 calibration. One number set will get you, I mean, coming from Keithley, this will get you within a 10% range of what the actual values are because every part set is different. So it'll be in the ballpark, but it's not going to be, 0.01% type of cal. Just a comment.
Yeah, we've found very little variation and surprisingly little in the triple eights. So that aspect of them has been pretty good. But yeah, there's always going to be. I don't think we expect to calibrate each site.
Yeah. And
Individually.
from production run to production run, when you get a different set of parts, you're going to get different results. But
Yeah,
it's better
well,
than not having anything.
Yeah,
A lot
well,
better.
well, hopefully of course, and the other variation in these systems will be the location, the QTH. I mean, if we hopefully we can, every site can have the same antenna, but that seems uh, pretty. I'm not sure that we can use the DX engineering or any antenna everywhere. We may not
Right.
be suitable everywhere.
Yeah,
So there's going to be that element of a component in the variation between receive sites that we can't avoid. I don't know that there's an easy way to calibrate. The field probe could be a help, in that way. You could do a survey, but we're now talking about asking the operators, the hosters of these sites to do RF field strength measurements that are probably they're very unfamiliar with and require equipment that they don't have, and so on.
that's a rabbit hole you don't want to go down.
Yeah, so
Trust me.
one of the great benefits of the single antenna, though, is that the latest designs incorporates a relay that shorts the antenna terminals. You can short it, and by doing so, you get an excellent indication of the quality of the receive site. So if you short the antenna terminals of a balanced antenna, all the signals should go down, by 20, 30, 40. And in the case of the Glenn single antenna, they go down by 50 dB. I mean, not at 10 meters, but at the lower frequencies. And that's a tremendous benefit way to and given that we'll have remote access, a knowledgeable operator, Michael, me, or someone can remotely access all of the Whisper Demon Grape sites are remotely accessible. We can do that once the operator is installed. That we can instruct the antenna system. I have to think about how to do that. Instruct it to short the dipole, and let's take a look at the spectrum. And if it goes down as we expect, then we know that whatever we're measuring is actually what's the differential signal that's appearing at the antenna. not the what's introduced by the ground loops and the wiring in the house. But need to think of this discussion reminds me. I need to think about how we could remotely control that. I mean, there's no, if we had a Raspberry Pi, there's GPIO pins you can, just control from the bash script. But a B-Link host doesn't have that. Doesn't have those I/O pins on it. So then you have to have some way to control. If you want to remotely control it, the antenna, you would need to have some kind of device that the host computer could talk to.
Caution, scope creep.
Yeah, yeah. Well,
Yeah, we are talking about amateur radio guys here. And a lot of this is really over the head of amateurs, in my humble opinion.
well, we were trying to make it so
Good.
well, yeah, the goal is to make it so that they don't have to know anything.
Right, well-
Minimize the amount of understanding on their part and interactions.
Yeah, and physical connect this to that and so on. But good science, though. I don't mean to put
No,
it down,
no,
but I'm just
no.
saying, remember your audience.
No, no. I exactly, and I agree. We're trying to make it as simple as possible, consistent with making sure that we know what the received site looks like. An ability to, at least for us, to know how good is this site. Is it, how good is the data we're getting, and without not asking the host of the site to do anything other than here or erect the antenna and let us look at it remotely. We'll tell you what to do. Anyway, that's the hope.
Okay. Any other questions, comments, discussion? All right, Dr. Kasdan, take it away.
Yeah. Oh, I was going to say, all of the Whisper Demon Grape sites are recording WWVB IQs. So those recording files are available. We just don't upload them. So if you want some data wave files, IQ wave, WWV wave files, I can email you or give you access to some. Okay.
Check our. David, are you still on?
Yeah, I'm here waiting for permission to talk.
Oh, go right ahead.
Okay. So WWVB is a unique resource. It's a good chunk of power in low frequency band. It's on 60 kilohertz. It's atomic clock regulated, just like WWV, and WWVH uses the same common look by microwave link from Boulder to north of Fort Collins. I'm blanking on the town name. And it has a couple of distinct modulations that are really pretty interesting. I think everybody here really knows this story, but what's called the legacy AM modulation is what runs most department store clocks that are labeled as atomic clock. And the amplitude modulation is phase locked with the carrier. So it's useful as a radar signal of opportunity, and we've been talking about doing matched filter detection of that to find time of flight for a good long time. The monitoring of the phase of the carrier got complicated a good long time ago when a station ID phase shift was put on the signal. I don't remember the exact numbers, but something like 10 seconds out of every 10 minutes, a 45-degree phase shift was put on so that chart recorders could have a little blip that distinguished WWVB from rugby radio in England, which was transmitting basically exactly the same thing. And for US East Coast users of the signal who were contractually obligated to use WWVB for their frequency accuracy. That this was put on as a convenience for them to verify their contracts. Then the East Coast users were further complaining they weren't getting adequate signal. WWVB was to have a second transmitter placed somewhere east. Negotiations went on, they fell through, it didn't happen. The German station had been using a phase shift method, and WWVB adopted it. So there's a phase shift signal that is layered on the amplitude signal, but it's independent of it. It's a different code. There is only one chipset out there that I know of that decodes it. There's only one consumer clock that uses that chipset. The chipset is Everset's ES100 chip. The clock is Lacrosse Technologies Ultra Atomic Clock. It's a nice thing. Okay. So I've been fussing with the ES100 chip myself. I want to learn how to use it. And I found in their documentation, do I have screen share, Rachel?
You can, yes.
All
I'll stop.
right. Do I have it now?
Everyone should be able to screen share.
Okay, let's take a look here then. All right, so I spotted this in Everset's documentation, and I did a double take when I saw this, that there are actually two different phase codes run. There's the regular one that your clock decodes, and then each hour on minutes 10 through 16 and minutes 40 through 46. The phase code is slowed down to molasses rate and sends only the minute. The notion is that if your clock got the signal sometime, so it's reasonably accurate, but it's in a noisy spot or it's in a low signal spot, or like the one in John's office, it's on a ground floor inner office in a steel reinforced building, then having the minutes only sent at 1/10 rate improves the link budget by a factor of 10. So this thing will pick a signal out from nowhere. And the Everset part is meticulously programmed to ignore these times because they didn't want to program it, I don't know. And when the unit starts up, if it's having trouble getting its time, it waits an amount of time appropriate so that just in case it happened to be trying to get it during this time that it can't decode, the next time will be out of that time. So, wow, that's really amazing. I had never heard of that one before, and I, being a nerd, wanted to know more. So I dropped a line to Matt Deutsch, the chief engineer at WWVB, and he said, "Oh, yeah, that, we had been doing it. And some years ago, I don't remember the exact time, but 6 or so years ago, somebody was making some measurements and asked if we could stop that for a little while. So we stopped it. And then we realized we didn't hear from anyone who was actually using it, whose system got broken by our not transmitting it. So we never restarted it. That's not there now, even though it's in WWVB's documentation as a short paragraph buried in the middle of their documents, and this ES100 has it where I learned about it. So if you're interested in such things, that's the story. A couple of other interesting things I found out. The phase shift takes place during the amplitude modulation signal's low time. So you still get maximum power recovery from the binary phase shift during high power times. That's good. And if you wish to track phase of WWVB, you need a squaring amplifier. So instead of running your signal at 60 kilohertz, you'll be running it at 120 kilohertz. That's the maneuver for bringing the vector of a binary phase shift keyed signal always into the right-hand plane, always in positive phase shift instead of positive and negative. So that's my story. I thought it was a good tale. I will stop sharing. More ways than one.
I can add to that.
Rachel
go.
recognizes you.
Okay. One thing, yeah, the Everset was originally going to come out with the ES200 chip,
that would implement that slow time code. And apparently they never came out with the chip, and therefore nobody's ever used that code.
Oh, that's the story. Okay.
Yes. Precious few of are using the phase code as it is. The other thing I will add, though, is that there is at least one discrete design out there to decode that. If you look back through the Time Nuts emails, one should be able to find that. And it is open source. Whoever designed it, I believe, put it out so that any one of us could implement it if we wished.
Oh, great fun. David, have you used the ES100 part?
In a sense, yes. I mean, I've used it. I've helped them test it at great distance. I took one of their units to Greenland when I was working over there, and it locked up just fine, except when the radar was running.
Okay, now more at the nuts and bolts level. My frustration for the past couple of days has been trying to get that part to communicate with a Raspberry Pi, and I just can't get the I2C line to work. I have some suspicion that I have a defective part, but that's not my first thought. So I must be doing something wrong.
Yeah. Well, did you get it from Universal Solder?
Yes.
Yeah. Did you get the evaluation board?
Yes.
Okay, so can you probe the board and see if there's any difference in how they're communicating with the part?
Well, maybe we're not talking about the same thing. I have the full carrier kit and their antenna kit. I can see the interrupts coming, although they're inverted from what the ES100 manual says. And I don't see anything on the I2C clock or data line.
Oh, interesting. Well, certainly communicating somehow.
Yeah, my guess is I'm doing something wrong, but I have put a good 10 hours into it already and I can't find it.
Interesting. Well, I don't think he's there anymore, but I used to work with the field rep at Everset. Have you tried gotten in touch with them?
No, I haven't.
I don't even, well, the chip's still available, so they must still exist, but I'm very surprised that it hasn't taken off as they'd hoped. The one thing that I was trying to get out of it was actual timing information, and it's really not designed for that.
No, it doesn't. The next level carrier board, the one that Lacrosse Technologies uses, it does have a pulse per second brought out. It's what they use to run their stepper motor. I think it must come from the interrupt signal. So I don't know that I would depend on it for close timing, but it is a test point brought out on the circuit board.
Right. But yeah, what the thought I had with that didn't go very far with it, but is use the ES100 to decode it so you know what the time is, so you know what the code actually is, and then sort of reverse demodulate it to get a constant phase out of it.
Yes, and actually that's that's along the lines of what John and I have been doing with the amplitude signal, to use a matched filter, to use it as a time of flight device.
Right. Yeah, it's really annoying though that they changed this and broke all the precision receivers that were using it for time and frequency transfer. And then nobody really implemented the new format.
For those who care, the Case Amateur Radio Club, radio station W8EDU, worked with Lacrosse Technologies to make up an ultra-atomic clock with a face in the form of a ship's radio room clock. It's a fundraiser for the club. If you would like one, let me know. It's very nice. They had us write up a descriptive page about it, so you'll be the only kid on your block with one.
So you say you did actually find a pulse per second coming out of the Lacrosse clock.
Yes, that's right.
Could you send me information of what that point is?
Yeah,
I've got some of them here too.
While we're talking, I'll see if I can find it.
Great, thank you. But yeah, also I would say go back. Do you know the Time Nuts remailer? John Ackerman runs that.
I'm aware of it. It's not one that I read regularly.
Right, but I mean, you should be able to go back into the archives and find this design if you're interested.
Okay, and I found that page. I will put it in the chat right now. Yeah, take a look at that one, Dave.
Ah, great, thank you.
But once again, if you want to buy one of these clocks in the form of Titanic's radio, or actually post-Titanic, Titanic might not have sank if it had had one of these, then, you know, you or the Californian had one of these, just let us know. The low, low price.
Is it? Okay.
Yes, that's the one. It's not in Lacrosse's catalog. I don't know why they don't have it listed. The serial number on it, if you choose to punch that into your telephone, will ring in the Case Ham Shack.
It's fair. Has our number changed since the 70s?
It has not, and when we install our new phones, we're seeing to it that we get the same phone number because of this.
Yeah, I think it has changed. I don't recall that number from the 80s when I was there.
I'll have to check into that. See if anybody ever wrote the phone number down in the Chronicle.
That's right.
Okay. Just gonna ask any other questions, comments, or concerns on clocks and WWB? Okay. Gamal, did you still want to give ray trace updates at this meeting when you can, or would you like to keep that to Monday meetings? Radio silent. Okay. In which case, does anyone have any other questions, comments, or concerns? Or business to discuss? All right. 73, everyone.
Stay well, folks.
Goodbye, 73.